This is video help for homework number 5. On problem number 1, you can refer back to section 5.1. I think that's on page 190. On problem number 2, what you're asked to do is find the cosine function for this voltage, and they give it to you in terms of a sine, so make sure that you use this trig identity, sine z equals cosine z minus 90 degrees. And for the VRMS, use 1 over the square root of 2 times the peak value. For the average power, this is not the average current times average voltage. If it was, it would really be 0. But the definition that we're using for average power is the RMS current times RMS voltage. If you work out the integral for this, you find out that it's not equal to the average current times the average voltage. Instead, it's the product of the two RMS values. And for this problem, remember that you can use Ohm's law, V is equal to IR, so that you can express this average power as the square of the RMS voltage over the resistance, and in the problem they give you the resistance. Make sure that you include this graph down here below, and you can use the capital T value that you get here to figure out what the period is of this. Also, you can look at the phase difference that you get, or the phase value set for that function, to figure out where the waveform starts. In fact, it asks you to find the time for the first peak, and you can show your work over here to the left hand side. I have an example that I just made up that I was going to work out. My example looks something like this, a little bit different than what you're working out. To find the value of the time, we're going to call it T sub P for the time for the first peak. What you do is you say that at the first peak, the value of the voltage is going to be 25. Remember that a cosine function can have a maximum of 1 and a minimum of minus 1. So we're going to see that once we fill in these values. Again, I just made up these values. These are probably not the values that are used in this particular homework problem. And I need to put a T sub P there because this is the time for the first peak. When you do this, you get a value of 1 on this side, and you get the cosine of 60 . Alright, we're solving for T sub P, and we're going to get that it's equal to the cosine, inverse cosine of 1 plus or minus, not plus or minus, but minus 60 degrees. Now what we need to do is express this number here in radians so that we can get an answer in seconds. So what we're going to do is say that pi radians is equal to 180 degrees. So that TP equals cosine, the inverse cosine of 1 minus, I guess that's pi divided by 3 radians for this, and over 60 pi radians per second. The possible values of the inverse cosine of 1 is, well, one of them is 0. If you plug this in here, you find out that you get a negative time. So that's really not anything we can plot on our graph. So, but you might notice that another value for this is 2 pi. taking the cosine of 2 pi will give you 1, taking the cosine of 0 will give you 1, 4 pi, and so forth. So these right here are going to give you the times for the peaks, but the question asks the time for the first peak, and in particular the time for the first peak where time is greater than 0. If you plug in a 0 here, you get a negative time, so that's not the one we want to use. We want to use this one right here instead. So the time for the first peak can be found by taking 2 pi radians minus pi over 3 radians, and divide all of that, once you find a number, divided by 60 pi radians per second. So here you're going to get a time that's greater than 0, and the answer will also be in seconds. Alright, again, this is a different problem than the one that you're asked to work on this page, but I hope that going through this example helps out.